Hello, welcome to the NORVI Industrial Controllers. Today we are working with the NORVI AI Optic, which is an ESP32-S3 camera-based product. I show you how to get started with this camera device, set up the Arduino programming environment, and explore the features of this device. So what is the NORVI AI Optic? It is an ESP32-S3-based edge camera with an LED flashlight, built-in battery, 2-inch display, and also microSD card support. To get started, we will use the Arduino IDE, since most of us are familiar with it, making it an easy way to begin working with this camera device. First, you can download the example program and the necessary libraries from our GitHub repository, which you can find from the user guide of this device. So, go to the NORVI official website, documentation, and here you can find the NORVI AIOptic user guide. Scroll down. From here you can go to the GitHub repository, or I'll leave the link as well in the description. So here is the GitHub repo and the libraries. You can download the zip file from here. I have already downloaded it. You also need to download the zip file. Let's open that folder. And inside this folder you can find the libraries and the Arduino example program. You need to replace these libraries in your Arduino library directory. Now I opened the example code in the Arduino IDE. This code is designed for the ESP32-S3 microcontroller to initialize and control the camera device, display images on the screen, and manage various parameters and hardware components via I2C devices. Let's quickly go through the code. First, we include the libraries that we need. Then we define the I2C addresses and the register addresses for the BQ charging IC, as well as here IO pin assignments. Next, we initialize the parameters and set up the arrays where each element represents a specific parameter. We also have variable for triggers and switches, and this part of the code is used to scroll through the menu and the setup function and the loop function. Now let's look at the display code. This code initializes the display and the JPEG decoder. Set up a callback for the image rendering and include function to the display the menu information and sensor readings. This DFT output function is a callback for a JPEG decoder used to display images on a screen. The display menu function updates the display to show a menu at the bottom along with the additional information. Moving on to the camera code, this section allows to configure and manage in the camera device. We define the GPIOs used for the camera, and the camera init function stores the camera configuration. We adjust the camera configuration based on the available VSRAM here. Then set sensor parameters, handle image capturing and display, and update the camera settings. Next, we have the code for the charging IC. Here the read register function read a single byte from a specific register of the device, and write register function write a single byte of a data to a specific register of the device. The read status function read and interprets the status registers of the device. And the config charge function configures various settings of the charger device. The config sys function configures the system registers based on the value of the 24th element in the parameters array. If the 23rd parameter's value is 1, the function writes 0 into 48 to the system register. Otherwise, it writes 0 into 40 to the system register. This code initializes IO devices, read their status, adjust settings based on the button inputs, and read the battery voltage, displaying the result while handling all errors. Now let's upload the code. Before that, we need to adjust some settings. So go to the tools menu, select the correct port and board. Then the flash size is 16 MB and the PS RAM is OPI PS RAM. Then I connect the USB cable to the camera device. After that, hit the upload button and wait for the code to upload. Okay, the code is uploaded. You can see that once the code is done uploading, the camera turns on and it will start streaming the live camera. If I move to this side, you can see this rotary switch, which is used for power up and adjust the camera parameters. If I push down the rotary switch, you can see the brightness goes down, and if I push up the rotary switch, then the brightness goes up. And if I pull the switch, you can see the camera parameters are changed. So there are a bunch of parameters that we can change. If I long press this to around 10 seconds and then release, the camera will turn off. And if I long press this for around 5 seconds, the camera will turn on. So this is the overall idea of this camera device. Let's see what kind of applications this device is made for. So what can you use the NORVI AIOptic for? Let me explain a few applications. First one is habitat monitoring. This means you can use the camera to keep an eye on natural habitats. It can help track wildlife activities, monitor changes in environment and ensure the habitat remains healthy. Second one is plant monitoring. This application is great for the agriculture or gardening. The camera can monitor plant growth, check for signs of disease, and even help with the automated watering system by analyzing the condition of the plants. Next one is image recognition. The camera can be trained to recognize different objects or patterns. This can be used in various fields like security to detect intruders, in retail to recognize products, or in industry to identify components. Next one is barcode reader. The NORVI AIOptic can also be used as a barcode reader. This is useful in warehouses, retail stores, and supply chain to quickly scan and process barcodes and making inventory management. Next one is people counter. Another handy application is counting people. This can be used in places like stores, offices, or events to keep track on the number of people entering and exiting. It helps in crowd management and ensuring safety regulations are met. So yeah, that was all about getting started with NORVI AI Optic camera. I'll try to cover the example code that will help you to get started and also make you understand what kind of application this device is made for.